So in this video, we will be covering learning objective 4, which is apply frontier molecular orbital theory to a proton transfer reaction. So first of all, what is the frontier molecular orbital theory? So it's kind of a concept that provides insight into how this reaction can occur, and it does it by the HOMO and the LUMO. So the highest occupied molecular orbital and the lowest unoccupied molecular orbital, which, as we know, is the base of all of the organic chemistry that we could do because it explains how all of the reactions happen, which HOMO reacts with which LUMO. Boom. So, in this case, we're trying to explain how it relates to the proton transfer reactions. So, the HOMO here will be the base, and the LUMO will be the acid. So, how are we doing this? So, to explain this, we're going to talk about the key factors that influence the proton transfer. So, first of all, one of the biggest things that we've talked about is the orbital alignment. So this proton transfer depends very much on the quality of the overlap of the orbitals of the HOMO and the LUMO. If the overlap is poor, the reaction will not be favorable. So the better the alignment of these orbitals, the better the electron flow and the better the transfer process. So it just makes it more effective. Second of all, the better the so we're going to talk about the orbital energy gap. The smaller the energy difference between the HOMO and the LUMO, so the highest the occupied orbital is, the highest in energy, and the lowest unoccupied orbital is, the better they're able to react together. It creates a very favorable reaction because their interactions are very favorable and the reactivity becomes better, much higher. So let's look at an example. So we have a strong base, and strong bases are going to have high homos, but very strong acids are going to have lower lumos. Therefore, this energy gap makes it very reactive, very favorable, and there is also an effective orbital interaction. The overlap depends on the molecules that are reacting together, the compounds, because if it's something really big and really small, that they have a poor orbital overlap, but we're not getting into this here. But yeah, so the smaller the gap between the HOMO and the LUMO, the better the reaction will be. Third of all, the molecular geometry does matter. Why? Because the orientation of the orbitals is so important for the alignment between the donor and acceptor orbitals, because this also enhances to the orbital overlap that I've been talking about, and it helps stabilize the transition state, which is very important because if the transition state is very kind of crazy, I'll say, it makes the reaction more unfavorable. So this proton transfer is done much more smoother and more energetically favorable, the better the orbitals overlap that I've mentioned multiple times now. So the better the overlap, the smaller the energy gap, the better the reaction is, the more it's reactive. But the molecular geometry, right? So they have to face each other the right way in order for them to overlap in an effective manner. So lastly, I will talk about the solvents. So we talked about the polar solvents in SN1 reaction, why they're important, but it's the same thing here. These polar solvents can stabilize the charged intermediates that form during the proton transfer. And also, they can influence the orbital energies and shift the reaction pathway by enhancing or reducing the effectiveness of the HOMO-LUMO interaction. So how I think of it as step one, whenever we're doing a a proton transfer reaction, we need to identify the acid and the base, which one is the proton donor and which one is the proton acceptor. So we're going to have acid as the proton donor and the base as the proton acceptor. We also have to identify the HOMO and the LUMO. So the acid, which is the donor, is going to have the LUMO, and well, they're both going to have a HOMO and a LUMO, but it's the highest one and the lowest one. That's what matters. And then we're going to say how they interact, the orbitals, and then we can make the reaction happen. But this is just very important to understand how HOMO and LUMO works in the first place. So to summarize, this is all very important based on the HOMO-LUMO interactions and the orbital overlap. The better the overlap, the smaller the energy gap, the more if the geometry of the molecules is just right, the better the overlap, and the reaction's more likely to happen more easily. The reactivity goes up, the stability, everything will go more smoothly due to these factors. And we can describe that using the frontier molecular orbital theory. Thank you.